Replicating IBM-DB and partitioned DB2 databases with Libelle BusinessShadow. This brief video presentation summarizes how Libelle BusinessShadow works for IBM's dashDB. We will outline the fundamental basics of Libelle's replication philosophy and key aspects of the Libelle replication solution in the context of partitioned dashDB databases. Libelle's replication philosophy is rooted in database layer replication. File-based and storage-based replication can be very problematic due to consistency issues. Transaction-based replication faces practical issues in day-to-day operation. Libelle achieves fully consistent replication by utilizing database redo log files. Only files that have been processed through the database log writer and formally released by the database are used for updating the standby landscape. This offers the advantage of absolute database layer consistency, as it follows a standard DB2 mechanism of backup and roll-forward recovery. Libelle utilizes small agents on source and standby systems to build and maintain replication. The key is full-scale automation when building and maintaining the standby landscape. There are 3 steps to build and maintain the replication. A one-time initial synchronization from production to standby known as the initial copy, a process for shipping log files from source to standby known as the archiver, and a process for roll-forward recovery on the standby system known as recover. Libelle BusinessShadow stands out as one of the most reliable standby database solutions on the market. It is particularly notable in the context of a dashDB concept called elasticity, the ability to grow and shrink the number of database nodes in a database instance. Elasticity in dashDB is implemented with a feature called MPP, which stands for Massive Parallel Processing, based on a DB2 feature called DPF, Database Partitioning Feature. With MPP, a single database instance can consist of 2, 10, or hundreds of database partitions on different servers which distribute the workload. Imagine a single database that runs on hundreds of servers in parallel. Partitions can be added and removed on the fly to accommodate changing requirements by scaling up and down as necessary. Libelle is the go-to solution to replicate this partitioned environment completely. Libelle provides an exact replica that is continuously updated with production changes. A database instance with hundreds of potential database nodes requires that all of these nodes are reliably replicated for disaster recovery purposes. Libelle BusinessShadow for dashDB answers this requirement. Distributed server agents manage replication, and a central monitoring intelligence manages and controls log shipping. Each node and replication configuration can be controlled individually, or all nodes can be controlled together. Just as MPP treats hundreds of nodes as one centrally managed database instance, Libelle can treat hundreds of nodes as one centrally managed replication instance. Once centralized, all replication activity can be coordinated intelligently. Log shipping can be synced across all source nodes, monitoring runs centrally, and, most importantly, the failover can be managed from the central interface. Central monitoring also allows for convenient mass managing of server agents, configuration settings, and remote updates if required. In the future, the central aspect will be expanded so that Libelle can more easily autoscale and detect additional nodes automatically to include in the replication configuration. Let's look at how BusinessShadow works in a practical example. We are going to have a closer look at a replicated 24-node dashDB environment that runs in the Libelle Labs in Stuttgart, Germany. This environment was installed using the standard dashDB MPP Docker containers and implemented across 3 systems. Each system runs Linux, has 64 gigabytes of memory, and holds 8 nodes totaling 24 production nodes for the landscape. This serves as our production dashDB MPP landscape. Next, we deploy the standby landscape with only dashDB binaries installed. The setup is exactly the same: 3 systems, 8 nodes per system, totaling 24 standby nodes. This is our standby landscape, which we will populate with production data. The Libelle BusinessShadow replication software is deployed on each production and standby system. Each production and standby system runs one Libelle server agent. Each server agent manages the 8 dashDB nodes on that system. An additional Libelle BusinessShadow central control unit is installed from a separate Docker image. The administrator connects via a web-based front-end to the administrator interface. The central control unit can then connect to the server agents to detect the dashDB landscape. Next, an initial copy process for all dashDB nodes is initiated to build the replicated environment, log shipping is activated, and the replication is up and running. Let's look at the example configuration from the previous illustration on the live Libelle Control Unit UI. The Libelle Central Control Unit provides the UI for building, monitoring, and managing replication. Currently, each of the 24 nodes is actively replicating. Libelle refers to the log shipping process on the production nodes as archiver and the log recovery on the standby nodes as recover. One designated node is controlling the roll-forward recovery on the standby landscape. Libelle provides a convenient interface to see the status of all nodes and their replication statuses, either as group view or list view with the option to zoom in for more details. Zooming in, one can view the status of each replication in more detail. On production, we see when the last log file was shipped and when the next log file is scheduled to be shipped. On the standby site, we see the exact recover status for that specific node. In the middle, between the two servers, we see the managed log queue. Libelle intentionally keeps logs queued up on the standby landscape to allow for point-in-time recovery to protect against corruption on production. In this example, we continuously keep the last 10 minutes worth of log files physically on the standby node, but have not yet applied them. With that, the standby node is always 10 minutes behind, but we can get current at any time. Libelle BusinessShadow keeps track of all activity and stores it. Historic activity can easily be pulled into the interface or exported for analysis. In the setup window, the configuration of each node can be set and edited. This includes the DB2 configuration for this specific node, database, and instance name, and all replication parameters. Besides the main window, the most important settings are copy, archiver, and recover. Let's look at them in more detail. Under copy, the initial copy parameters are set, which is the first step in building the replication. This is set prior to the initial copy. There are different ways to do an initial copy. We can do an initial copy via backup files, which is a 3-step sequential process involving a DB backup, then copying the backup files, then restoring on the standby node. Copy via named pipes follows the same workflow, but pipes the backup directly to the standby node so that the restore is executed while the backup still runs. Libelle also supports compression and dashDB encryption. Under Archiver, we set the parameters for how logs are copied to the standby node. A maximum switch time encourages dashDB to release online log files if they are not released after a specific interval to ensure recovery points. Log files can be shipped in parallel during high workloads. Libelle can clean up log files after they have been shipped, typically when working with a second log destination so that Libelle works out of its own log directory. Finally, Libelle checks with the database to ensure the log is actually released prior to copying it. Under Recover, we set up how the roll-forward recovery should be managed. We configure the recovery delay, cleanup options, and can pre-populate failover parameters. Additional interfaces provide options for directory or user mapping in case production and standby systems have different requirements. The alarm feature issues warnings and error notifications. The interface feature sets the network interfaces that are used for replication. Each node has its own configuration window and can be managed and set individually. However, there are a multitude of options to mass configure the environment by setting parameters for all nodes with one command. Let's look at the master configuration. Currently, the master configuration can auto-detect the DPF landscape and start and stop the archiver, recover, and copy processes for all nodes. Extensive additional mass updates are possible via the dbShadow command line interface. Stopping the archiver on the master nodes will issue a stop archiver command to all 24 nodes, and archiver is stopped for the complete landscape. This is just one example of mass configuration management. Let's summarize what Libelle for dashDB can do. Libelle replication supports a wide variety of systems. From a platform perspective, Libelle can run on Linux, Power on Linux, Windows, and most common Unix systems including AIX. Libelle supports DB2, DB2 DPF, dashDB, and dashDB MPP. DB2 Blue acceleration is also fully supported as log files are not affected. Generally, replication needs to run between the same landscape, so it is suggested to be run between DB2 to DB2 and dashDB to dashDB. Cross-DB or cross-operating system replication is not supported as log files are typically not compatible. Libelle supports an unlimited number of nodes and has no distance limitation when replicating. Libelle's replication architecture is the perfect solution for large-scale automation and optimization of replication environments. Using the most reliable method for replication, it offers the best approach for ensuring the standby landscape is consistent and ready to take over production if necessary. The standardized replication method encourages customers to standardize and fully document the replication approach for compliance. Finally, the convenient interface makes it easy to manage large-scale replication. Please reach out to Libelle at any time with questions or to schedule a demo.